Good morning, everyone. Warm welcome on behalf of Department of Geography, Adamas University. It's 11:30, and as we know that today the weather is not very good, so just wait for 2 more minutes, and then we will start our discussion. Right? Just wait for 2 more minutes so that more participants can join, and then we'll start very soon. Thank you for your patience. Good morning, sir.
Good morning.
Morning, sir.
Sir, we are just waiting for 2 more minutes, and then we will start.
Sure.
Thank you, sir. I would request all the participants, please mute yourself. And participating in the tree planting campaigns that is done. From their natural resources. Okay. Today I just discussed deforestation. Hello.
Hello.
Okay. Am I audible to everyone?
Yes.
Thank you. So a very good morning, everyone. I, Dr. Anu Rai, on behalf of Department of Geography, Adamas University, welcome you all on this auspicious occasion to celebrate World Ocean Day 2021. I know you all are wonder why we have not celebrated our World Ocean Day on its actual date, that is 8th June. Just because of our end term examinations were going on, so we haven't managed to do that on this 8th June. So we believe that it's never too late to celebrate or raise the awareness about the well-being of our nature. So we have decided that's okay. On 8th June, if we cannot celebrate, let's select some other day to think about the well-being of our nature, the well-being of our ocean. So again, I welcome you all to raise the awareness to celebrate the World Ocean Day on behalf of Department of Geography, School of Basic and Applied Sciences, Adamas University. So we all know that the ocean that covers the 70% of our planet, it also provides the 50% to the oxygen for entire planet. And most of us, we know that in Bengal, not only in Bengal, but the oceans are the major sources of protein for the billions of population throughout our globe. And it's also the 40% of global economy is dependent on the ocean, right? So on by giving too much of this resources, the oceans are in real threat right now. And we are really, being a geographer, we are really concerned about our nature, and we really want to raise the awareness, like how we can conserve our nature, how we can conserve our resources, and how we can conserve or think something about our oceans, right? So let's start our this campaign. We can say that it's a awareness camp, and let's start our World Ocean Day celebration. And we would like to invite Professor Sanjeev Ghosh sir to inaugurate this session. Sir, are you here, sir?
Yeah, I am here, but where, I thought that Professor Pandey will be there. No, he's not there.
Sir, because of certain meetings he is engaged, so I request you on behalf of Department of Geography, Adamas University, please inaugurate the session.
Okay. Good morning to everybody, all participants, and thanks Geography Department for asking me or inviting me to inaugurate. It's a nice opportunity, and this is a great I should say meeting to celebrate the Ocean Day, which is so important in this current situation. Now, first of all, I want to introduce a little bit about our university to the participants. There should be participants who are new to this particular program. So Adamas University started its journey from 2015. 2014, actually, we got the clearance from the Higher Education Department, Government of West Bengal, and we started the university in 2015. And right now, we have several schools, including this school, a School of Basic and Applied Science, and then we have School of Life Science and Biotechnology. We have Pharmacy Department, we have Engineering Department, we have Law, Media Science, Economics Department, and so on and so forth, Education Department. So, and also we are going to, it's very important in this context that we are going to open this year that Smart Agriculture, School of Smart Agriculture, which depends so much on the climate. So this seminar or this panel discussion will be very important for all of us, particularly for the faculty members and students of this university. Now, regarding this university, the first thing we remembered, or we started with the mission or vision on the very first day, that this university is not just a mere another university, but this university situated in that Adamas World City, which is situated in Barasat, having more than 100 acres of land. It's a very green campus. When we started, we have the motto or the mission is that we should not only share acquired knowledge to our students, but from the very beginning of the university, we wanted to create knowledge. That means research was given the prime importance with teaching. So two goals of a good university, famous university, are the one is innovative teaching. How can I motivate students for their future, whatever way, their job or their higher study or the research? And second thing is doing research by ourselves. The faculty members, students also do research and create new knowledge. That is our motto. And keeping this in mind, from the very beginning, we have hired faculty or recruited faculty members with that in mind. For example, Dr. Onurai is one example, one of my students also in Presidency College. And there are so many students of my students and other faculty members. They are very, very, I should say, appropriate for these two purposes. That is, they are capable of doing innovative teaching. They have proved that, and many of us are doing very good research. In fact, we have several DST projects that we have got by our faculty members in chemistry department, in physics department, and life science departments. And there are other industry-driven projects also by physics, geography, and as well as engineering departments. So research is the prime goal for university, not just mere teaching. And teaching also, we are trying to focus not only to cover the syllabus, but we have designed the syllabus so that our students at the undergraduate level as well as the postgraduate level, they are engaged some way or other in the research. That is, about 1/4 of the marks have been allotted, particularly for all departments under undergraduate, also under postgraduate section, that they should do certain projects. This will benefit not only the students, but benefit our university as well as our faculty members. They can carry out the research through their students. So we are doing this. Now, today, uh, not only today's session is an panel discussion, kind of this discussion. We have lot of this thing we are doing not only during this pandemic period, before the pandemic period. Is a regular feature of our university that we invite speakers. We are doing international as well as national level seminar or one-day workshop or 1 week workshop. Geography department is a leading one. They have arranged lots of workshops on remote sensing and other aspects of climatology and many other aspects of geography. So this is not a new thing for our university. This is another day that we are going to enlighten by learning something about ocean and climatology and all these things. I should like to mention also that we have been able to arrange lecture by a Nobel laureate in chemistry during this pandemic period, where the lecture was 2 hours duration. And am I audible, Anu?
Yes, sir.
Yes, sir.
Okay.
Very much.
And 1,200 participants were there on the Zoom as well as the YouTube. We have 1,200 participants. They participated in that particular lecture by a Nobel laureate from Strasbourg University. He is one of my mentors, actually, Dr. Jean-Marie Laine, and he created a new world in chemistry. Anyway, that is not the subject of today. Today's subject is, the ocean and climatology, as I understand. And climatology is so important, not only for geography. Every people, whoever may not be geographer, may not be anybody, chemist, physicist, or even the common people, they understand what is meant by climate, what is meant by ocean, because they go to the ocean very often for a traveling or something to see the nature. But nature's beauty is one thing, but nature's devastation is another thing. And we have confronted recently, the last year, the Amphan, and this year, the years. And the remote sensing, weather science, and climatology has advanced to an extent that we can predict everything beforehand and save so many lives. So this climatology and associated subjects like weather and weather science, I want to mean, and then this effect of climates on human beings, effect of climates on forests, effect of climates on agriculture, because agriculture is so much important because we get food from this. So everything getting affected if you get a climate change. Every people know if the surface temperature of sea changes little bit, very little bit, then there is a huge change in climatology, and we are all facing that. So even this this pandemic that we are going through, probably connected to the nature and some kind of climates. I don't know. The people are working on this. What is the effect of climate on this? On the transmission of this disease and things like that. So knowing the ocean, as Dr. Onurai mentioned, the oceans gives us a lot, but also takes from us a lot. So what is ocean? How they are functioning, and connected or associated with this is the weather science as well as the climatology. Climatology is a subject, not only local subject; it's a globally important. All of you know, and there are lots of international body who look after climatology. So geography department is one of the leading department in our school. They are not only offering courses in geography, but they're specialized faculty members for offering courses in remote science, as well as climatology and environmental science. So I hope today's panel discussion, we will learn everything about this. And I think this seminar or this panel discussion will be helpful to not only our faculty members, but to all of our students, and they will be enlightened by knowing something, at least, about ocean and climatology and weather science and remote sensing. So with these few words, I hand over to Anu to continue the panel discussion. Thank you, Anu.
Thank you very much, sir. You are always the point which like inspired us a lot. And thank you very much for your such an enlightening inaugural speech. Now I would request my co-host, Dr. Supratim Karmakar, to continue the session. Thank you, sir.
Thank you, Professor Sanjeev Ghosh, for his gracious presence and for his support. Now, I would like to invite our departmental head, Dr. Kosturi Mukherjee. Dr. Kosturi Mukherjee is Associate Professor and Head of the Department of Geography in Adamas University and visiting researcher in Stockholm Resilience Center, Stockholm University. She has received her PhD on urban climate from the University of Calcutta. Dr. Mukherjee has completed post-graduation degree in geography with specialization in environmental geography and post-graduation diploma in geoinformatics. She is a gold medalist for securing first rank in the university in post-graduation, and she has received Best Paper Award 2 times in 2010 and 2018. Her research interest is focused on urban climate, sustainable development, peri-urban development. Now, I would request Dr. Kosturi Mukherjee to introduce our department and say a few words. Over to you, Dr. Mukherjee.
Thank you, Supratim, for this wonderful introduction. And I thank sir. Already Professor Sanjeev Ghosh has mentioned many things about our department. I just would, if I'm allowed for 2 minutes, I just would like to show you a brief presentation about the department, what we are doing in our department, how we are trying to build up our department. As university is very new, so also our department. So we are trying really very hard to collaborate to develop our department. So I'm just sharing my screen. Just give me 2 minutes to finish. This is a very large presentation, but I'll be very quick. So this is the faculty strength we are having presently in our department, and we offer this 6 programs, and MSc Geoinformatics is something that we are going to launch from this academic semester, along with the BSc MSc Geography, integrated MSc in Geography Geoinformatics, PG Diploma in Geoinformatics and Geostatistics, and of course PhD program. So apart from following the CBCS system that all other universities are following, we are also putting lots of emphasis on remote sensing, mathematics, science, statistics, and very unique specializations like hydrometeorology we are offering in master degree program, because we believe that geographers, once they have learned about the applications of remote sensing, while they have learned the surveying techniques, they can't be unemployed. Academics cannot be the only option for the geographers. So we are putting a lot of emphasis on the tools and techniques and the courses that are required for absorbing the students in the industries. And we have placements, we have internship, of compulsory internship within the course. And dissertation to publication is something we are encouraging a lot for the master degree students, that their dissertation should be a good quality dissertation that should be publishable in the any journal or conference proceeding or book chapter, but that must be Scopus index. So something good but difficult decisions we have taken, that they need to publish their dissertation in within that time period they are in the Adamas University. Apart from putting lots of emphasis in incorporating remote sensing into the subject curriculum, we are also incorporated the analysis of big data, computer programming, and machine learning techniques within the course curriculum of master degree MSc Geography, MSc Geoinformatics. And of course, as I was saying, that there are lots of opportunities for the geographers that are coming up, because they are learning new techniques. They are becoming experts in the data analysis, in analysis the climate, analysis the oceans, analyzing the various aspects of the earth through remote sensing. And we have collaborations with national universities and international ranked universities. And of course, we are very new, so we do not have, we have these 4 laboratories with us. And during this pandemic also, we are trying to, like, not for a single day our teaching learning was stopped since the last academic year. And we are encouraging a lot our students to participate in various conferences, present their research work. Even UG students, master degree, of course, even UG students are presenting their research works in various forums. And we used to organize, as Sanjeev Ghosh sir mentioned, lots of extracurricular, co-curricular activities, and through this we try to collaborate with the very good leading institutes and universities of India and of the world. So once this pandemic is over, definitely we would like to meet you physically, all of you, in our campus, especially our esteemed guests that we are having today. Definitely we would like to have them in our campus. So these are few pictures of the activities that we are doing before lockdown and after lockdowns as well. One thing that I would like to mention, that not only this uh, academic gathering, apart from the academic gathering, we are trying to have some industry gathering. There's few industries which are working with the geographers, with the skill of GIS, remote sensing, surveying. We are trying to gather them. We are trying to understand that what are the need of the industries to absorb the geographers into their companies. So whenever some kind of initiatives once again will be there, we will be informing you, and we will be very glad if you join us in this endeavors. We had international conferences with within this pandemic time as well. And that's it. That's all about, that's a very brief introduction about the department. Once we will meet after the pandemic, definitely we'll have a good interaction, more interactions. Thank you. Here I stop my presentation and hand over the mic to Supratim.
Thank you for this nice presentation and letting all our participants know about the activities and about the credentials the department has. Thank you very much. Now, I would like to request again, Dr. Mukherjee, please enlighten us with today's topic, to the core theme of the panel discussion. I will like to request you again.
Okay. Thank you. So after this introduction of our university by Professor Sanjeev Ghosh and introducing our department to all of you, now we should move, as Supratim said, move forward to the main theme of today's panel discussion. And we have we are honored to have various experts with us. We will be learning from them more about the impact of ocean, about the impact of climate change on oceans. I will like to introduce to you the very basic features of climate change. What is climate change in general, what we mean by climate change, and what are the impacts of climate change that we are having on the ocean in a very generalized way. So once again, I'll be sharing my screen and for one presentation. Okay. Is my presentation visible?
Yes.
Yes.
Visible. Okay. So my topic is changing climate of the world and a few impact of this changing climate on the oceans, how oceans are being affected. So before starting this, I thought of starting from the very beginning of climate change and very beginning what we mean by climate. So as we can see that few hours back in my place, it was raining. Now rain has stopped, a little bit sunshine I can see. So this is weather. This is what we call weather, that changes rapidly, quickly. But climate is something that we all know that it doesn't change very rapidly, because it's an average of minimum 30 years. So, but scientists have discovered that due to certain human-induced activities, human-induced impacts, our climate, the world climate is also started to change. Maybe it's very little change in terms of quantification of temperature, precipitation, the basic parameters of climate, but it is changing. And mostly scientists have pointed out that this change is occurring because of the global warming. So let us understand what is global warming and how it is creating this change. So as we know that we used to get the sunlight from the sun, we used to get the energy, all our energies of the earth are received from the sun. This sun energy hits the earth's surface, and also from the earth's surface it is re-radiated back to the space. This we call as the heat budget of the earth's surface. This is very important to maintain the energy balance of the earth's surface, that the incoming solar radiation must be reflected back also to the space. But after it is reflected, there are some gases, there are some particles which traps the energy a little bit, not the entire energy, but little bit of energy has been trapped, and it makes our environment, that makes our climate of the world makes very conducive to living. Without without these gases, our earth would have been very cold, like it would be minus 18 degree. Water vapor, carbon dioxide, methane, nitrous oxide, these are the greenhouse gases basically that traps the re-radiated, reflected solar radiation and keeps our earth warm. So these gases are called greenhouse gases. Now this is good. This is a good thing. Otherwise, in absence of these gases, our earth would have been very cold. But what happens if the gases increases a lot in amount in the atmosphere? It has been seen that since the industrial revolution, since the last 100 years, continuously carbon dioxide, methane and nitrous oxides are increasing. So definitely it is completely human activity. Because of more industrialization, because of more burning of fossil fuels, diesels, coals, the gases are increasing. So more gases means that more greenhouse effects. So a little bit of greenhouse effect was important, but when it has become greenhouse effect has become more heat has been stored, trapped in the earth's surface, we are experiencing temperature increase. And since 1880s, we have seen the temperature increase of one temperature increase by 1 degree or 2 degree, and if this trend continues, it is going to be higher in the coming decades as well. So it seems very less, like 1 degree or 2 degree temperature increase, but think of a situation when our body temperature is increased by 1 degree or 2 degree, we feel sick. So also our earth, if the temperature is increased by 1 degree or 2 degree, it is going to affect the entire climatic system, because climate is not something which is very isolated and single entity. Climate happens. Yeah, thanks. So climate arises from the interaction of atmosphere, hydrosphere, cryosphere, lithosphere, and biosphere. So all the spheres interact and our climate system originates. And when the temperature has increased by 1 degree or 2 degree, all these spheres are going to be affected a lot. So because today is World Ocean Day, we will be in the rest of my presentation, I will be discussing very general thing about the impact of this temperature increase on the oceans. So oceans, as Anu said initially, that in the very beginning, that it covers almost 70% of the earth's surface, and it holds 97% of the earth's water, and it receives 80% of rainfall. So that the change in temperature is massively going to affect our oceans. This increased heat, the increased amount of heat that has been trapped by the heat trapping gases, that is going to be absorbed in a large amount by our oceans, because oceans, in comparison to atmosphere, continents and ice, ocean absorbs more amount of heat within itself. So when we heat up some water, what happens is that the molecules are going apart, it takes up more spaces. This we call thermal expansion. So this happens with our oceans as well. 1 degree centigrade of temperature increase in the tropical region is going to rise the sea level by about 3 centimeters. So thermal expansion is something we are going to face. We're not going to face, we are facing because of the global warming. And once the temperature, sea surface temperature has increased, you can understand that it is going to have an immediate impact on the atmosphere, that is in the local atmosphere. There will be more storms, there will be more cyclones, and I'm sure in the latter half of the panel discussion we are going to learn about these things, how the climate in a large scale is going to affect by the warming of oceans. Another thing that happens because of the global warming is the shrinking of ice sheets. So in both Antarctica and Greenland, we are facing ice loss, and in Greenland it is even more alarming. So in the next slide, I have one small animation. Just see, I hope that it's visible, like how Antarctic ice loss is happening from 2002 to 2016, and the Greenland ice loss. And this orangish and the reddish lines, reddish areas are showing those areas which have experienced ice loss in this time period, and white areas are intact areas, like it has not much affected by the ice loss. So Greenland is experiencing a lot ice loss. So where this ice is going after losing its original place, it is melted and it is going to be deposited in the oceans finally. So because of the thermal expansion of seawater and because of this added water from this melting ice, we are having the sea level rise. So addition of heat and addition of fresh water is going to total rise of the sea level. And this has been observed that 3.3 millimeter per year is the rate of change of sea level all over the world. And once the sea level is rising, then definitely first the coastal ecosystem, the coastal landscape is going to be affected. Eventually the inland areas is going to be affected. It will destroy the landscape, it will destroy the agricultural areas by saline water intrusion, it will destroy the aquifer, the groundwater storage, and massively destroy the coastal ecosystem, because coastal ecosystems are that ecosystem which protects us from these cyclones, from the bad impacts of the climate change. So once it is lost, there will be no protection from the storms, the shoreline will be eroded, there will be loss of habitats for the fisheries and all other endangered species, and this going to be definitely going to have an impact on food security. And more importantly, we will have a loss of coastal blue-green carbon, which plays a very important role in reducing the impact of climate change on oceans. So here I stop my presentation, and I hope that in the latter half of this panel discussion, we are going to learn more about these impacts. Thank you.
Thank you. Thank you, Dr. Kosturi Mukherjee, for giving us really a beautiful presentation of how the climate change is actually affecting our oceans. And actually here we also get some interesting questions about the ocean and about this carbon influx within the oceans, right? So to answer certain, I think there are certain questions that came in my mind, like how this climate change is affecting our ocean directly. Is there like how the carbon emissions are directly affecting our oceans? We also have heard certain terms like CO2 fluxes or the carbon flux in oceans or the blue carbon, right? So I think these questions can be better answered by our next panelist, Dr. Anirban Akhand. I invite you, Dr. Anirban Akhand, and I would like to introduce Dr. Akhand. He is a postdoctoral researcher at the Coastal and Estuarian Environmental Research Group, Port and Airport Research Institute in Japan. He has served several years of research experience in the field of the carbonate system of estuary, coast and ocean, blue carbon, ocean acidification, climate change, phytoplankton, air water carbon dioxide exchange, nutrients, biogeochemistry of the mangrove ecosystem, and environmental botany. He has more than 45 peer-reviewed papers and many chapters, and he is not like he is also the recipient of many international prestigious awards from the Japan Geoscience Union, European Geoscience Union, American Geophysics Union, Open Science Conference of the Surface Ocean Lower Atmospheric Study, and many others. So I invite Dr. Anirban Akhand on this panel discussion. And I have some basic questions to you, like, can you explain us what is blue carbon and what is the importance of studying this blue carbon in context of the estuaries and the coast?
Thank you, Dr. Rai. And am I audible? Am I audible?
Yes.
Yes, you are.
Yes.
Okay.
Okay.
Thank you, Dr. Rai, and thanks to the authority of the Geography Department of Adamas University for inviting me.
I would take just another minute to introduce you, Dr. Okay, no issue, sir. Please continue, sir. So continue. It was a technical error at my side. Extremely sorry. Please continue.
Okay, no problem. Thanks to the authority of the Geography Department of the Adamas University for inviting me to this panel discussion. And today's topic is blue carbon. So the term blue carbon has been introduced first by the Nailman et al. And the blue carbon meaning is actually the carbon sequestered by the marine living organisms in the oceans. That is the blue carbon in short. And I would like to present my slides to explain more. I am sharing my screen. Is it okay?
No, it is not visible.
No, it is not visible yet.
Share screen.
So first click on the share screen, then select your slide, the presentation, and then you have to click on share again, the new window.
Yes, that is I'm doing.
Might be it's a technical error. It will take some time. You just please try again.
Yes, it is coming now. Let's start.
Yes.
Yes, sir. Now it is here.
Okay.
Okay.
So first, before getting to the blue carbon, I would like to say something about the carbon cycle of the oceans. So as Dr. Mukherjee told that the carbon dioxide concentration is increasing day by day, and the present carbon dioxide concentration is now about 410 ppm we are facing. And the ocean temperature of ocean is increasing, and the ocean heating is much more than the land and atmosphere. So why should we study the carbon dynamics? What is the relevance? What is the importance? So carbon is a fundamental building block of all forms of life, and carbon is an important component of many biogeochemical processes, and human beings are capable of altering the carbonate equilibrium in the planet Earth. And carbon is one of the principal component of several greenhouse gases. As we know that carbon dioxide and methane are the two important greenhouse gases, and the carbon cycle is tied to the availability of other essential elements and compounds, which are also of immense importance to several natural processes. So in the ocean, what are the forms of carbon? So in the ocean, the carbon stays as a particulate organic carbon, dissolved organic carbon, dissolved inorganic carbon, and particulate inorganic carbon. And these carbon forms, also called carbon species, are interconvertible between each other. For example, there are several processes are involved. For example, with respiration, the POC can be converted into DIC, and by primary production, DIC can be converted to POC. And there are other two important processes, calcium carbonate precipitation and calcium carbonate dissolution, where the DIC and PIC change their forms with each other. And this is the main flow, carbon flow of the oceans. In the oceans, there are many processes involved in this carbon flow. For example, ocean atmosphere exchange, marine biota, biological pump, upwelling, downwelling, sedimentation, etc. So total carbon pool at the Earth's surface for duration of less than 10,000 years is approximately 40,000 gigatons, and there are mainly three pumps that works for storage of carbon in the ocean. These three pumps are the solubility pump, the carbonate pump, and the biological pump. The solubility pump is somewhat related to physicochemical processes, and like CO2 solubility and its relationship with temperature and thermohaline circulation. The biological pump, where the phytoplankton is playing a major role, the part of the oceanic carbon cycle responsible for the cycling of the organic matter formed mainly by the phytoplankton during photosynthesis, and carbonate pump, that is precipitation of calcium carbonate. These are the input of the carbon in the ocean. The main inputs are rivers, which contribute mainly in the form of DIC, and there are also other forms like POC and DOC. And before the Industrial Revolution, the ocean was source of CO2 to the atmosphere. That is a Royal Society report of 2005. And at present, the oceans absorb an average of 2.2 petagram carbon per year. And there are also outputs. As we know, the carbon is flowing to the ocean and going out. The organic matter preservation by sedimentation in the abyssal plain is the output. Refractory dome deposition in the ocean floor, sequestration in the form of blue carbon. These are the output of carbon in the ocean. So there are different colors of carbon. As we know that the green plants which sequestered, green land plants which sequestered carbon in the land part, that is called green carbon, and the black carbon as shoot particles and brown carbon as aerosols. In the same way, there is a blue carbon, as Neilman first coined this term. The blue carbon is the biomass and sediment, and also the degraded non-living part of the marine organisms, which sequestered the carbon for a long time in a millennium scale or more than 1,000 years. That is called blue carbon. Mainly, the mangrove, seagrass, and salt marsh has been unanimously declared as the blue carbon ecosystems. As you can see, 1 acre of mangrove can sequester 1,450 pounds of carbon, and seagrass and salt marsh can also sequester a huge amount of carbon in 1 acre of their ecosystems. And I would like to emphasize about the mangroves, because in unit area, mangrove can sequester the much more carbon than other ecosystems, other blue carbon ecosystems. So these are specialized ecosystems that develop along the intertidal zones of estuaries, sea coast, and it generally occurs in the tropical region and warm temperate region also, but not in cold region, because it cannot tolerate the cold. And there are some uniqueness of mangroves. We know there is a special kind of adaptation for salt tolerance, like viviparous germination, stilt root, pneumatophores, and it fixes the carbon hugely in its sediment, and the below ground biomass below ground biomass and sediment store more carbon than their above ground biomass. So there are mainly three kinds of fluxes, CO2 fluxes in mangrove ecosystems. If we take the example of Sundarban, so there are atmosphere and biosphere carbon dioxide flux. There are air water CO2 flux, and there are soil CO2 efflux. The soil and water of the mangrove ecosystem are generally net source for CO2, but the atmosphere biosphere CO2 flux is a huge influx, and that is why in totality mangrove ecosystems is a net influx for CO2. So in our Sundarban, we know throughout the world there are massive loss of carbon, and some scientists also says that the mangrove can be totally vanished in 100 years or something like that. But there is also restoration processes, and recently there is a paper published by Dr. Daniel Fries that there is a much hope for the carbon mangrove restoration throughout the world. This is an estimation in the Sundarban. The red area is the loss of mangroves within the years 1975 to 2013. It is amongst this total loss, 60% was washed away by the erosion, 23% was converted into the barren lands, and the rest were anthropogenically transformed into other land forms like aquaculture or something like that. So after sequestration, what is the fate of this carbon in the mangrove ecosystem? This picture shows that some parts are going to the ocean as particulate organic carbon, dissolved organic carbon, and dissolved inorganic carbon, and some parts are consumed by the fauna and consumed by the fauna directly or after export to the aquatic ecosystems like fish and other aquatic ecosystems, and a large amount is deposited deep in the sediment for longer period. So that is this part that deposited in the sediment for longer period, and the below ground part is the most important part of the blue carbon that is stored for a long time and can mitigate the climate change and CO2 emission. So at last, I will just mention that a paper of Lovelock and Duarte 2019 that there are many potential blue carbon ecosystems other than mangroves, tidal salt marsh or tidal marsh, and seagrass, like freshwater tidal forest, macroalgae, phytoplankton, coral reef, marine fauna, oyster reefs, mudflats, etc. They also have some potential to sequester carbon, but in this paper, Lovelock and Duarte, they mentioned some criteria for the blue carbon ecosystems and their management. For example, scale of greenhouse gas removals or emissions and long-term storage of fixed CO2, undesirable anthropogenic impacts on the ecosystems, whether management is practical, possible to maintain, and interventions have no social environmental harm, and so on. So you can see mangrove, tidal marsh, seagrass, and salt marsh. These are the 3 or 4 ecosystems that can fulfill almost all of these criteria. But other ecosystems like macroalgae or phytoplankton, coral reef, these ecosystems cannot fulfill all the criteria. So there is proposals for inclusion of these ecosystems also as a blue carbon ecosystem, but there are controversies also, and scientists have not unanimously accepted those ecosystems. Only mangrove, salt marsh, tidal marsh, and seagrass has been accepted. Thank you.
Thank you, Dr. Akhan, for this insightful presentation and to let us know about the very interesting topic and very relevant issue of blue carbon, and highlighting various aspects of carbon influx and how it is impacting our environment, the ecosystem, and the various aspects starting from land use to every aspect of our environment. And especially thank you for highlighting the impact on climate of Sundarban area, which is now facing day to day, the environmental situation is deteriorating day by day, and the climatic issues or the climatic disasters are happening in that area. It becomes more and more relevant to discuss about this area especially, and this issue of carbon influx is very important. Behind those all the disasters that is going on, and from here, from that point, one thing is very clear that the marine pollution or ocean pollution, coastal pollution is very much important, and it is growing day by day. From your presentation or from your lecture, we come to understand about this thing. And now on this point, I would like to invite Dr. Obro Chandra to throw some light on some issues like marine pollution and the coastal pollutants, and how they're impacting our climate and our overall environment, and what are the future scopes of research in this very poignant field. And before he gives his thoughts and shares his thoughts with us, I would like to introduce Dr. Chandra. Dr. Obro Chandra, presently an assistant professor in the School of Oceanographic Studies, Jadavpur University. He has 11 years of research experience in the field of chemical oceanography and environmental chemistry. His research interests mostly encompass domains like lentic and lotic biochemistry, coastal pollution, heavy metal dynamics, wetland biogeochemistry, with special emphasis on greenhouse gas exchange from vegetative structures, soils, and water surfaces. He has exclusively worked in the Sundarban mangroves and the adjoining estuaries, East Calcutta wetland, Bhitorkonika mangroves, and Dhamra estuary, and also in the offshore waters of northern Bay of Bengal. He has also carried out research on the mangrove, seagrass coral continuum in the Iramoti Island, Japan, in collaboration with Port and Airport Research Institute, Japan. At present, he has 75 publications on his credit, which includes 8 book chapters. Now, I would like to request that Dr. Obrajandru, please share your thoughts, like what are the scopes, how we can proceed in the field of study about like marine and coastal pollution. What are the scopes for our future students and scholars in this field? Over to you, sir.
Thank you. Thank you so much. First of all, I would like to thank each and every one of you for allowing me to be a part of this wonderful endeavor, I must say. Moving on to coastal pollution or marine pollution, as we say, I would like to share this with all the participants that most of us, most of the common people in the present date, the perception regarding oceans to us somehow lies in the fact that whenever we think of oceans, we imagine or we try and consider the huge water mass that lies in front of us whenever we go to a sea beach for tourism activity or something like that. But many of us, we don't usually consider the coastal areas or the land ocean transition zone as a part of the marine ecosystem. However, these regions are equally important and perhaps the most biogeochemically dynamic systems rather than the vast expanses of the ocean. So there are at present several issues which require scientific attention. It has been already paid by the global scientific community. However, I would like to highlight some of those issues. Say, for example, in present day, the nutrient use or the use of agricultural fertilizers have drastically increased to meet the food demand. And we all know that these inorganic fertilizers, which contains nitrogen containing fertilizers and all, they eventually end up in the ocean through runoffs, through land driven runoffs driven by monsoonal rain or something like that. And eventually they increase the nutrient levels to such an extent that it causes a phenomena which we all know, or many of us know, as eutrophication. So coastal eutrophication has become a severe problem. Now, why is this a problem? Nutrients are extremely essential actually for the phytoplankton growth. As my earlier speaker, Dr. Akhand, was saying, that phytoplankton and their dynamics is extremely crucial from the perspective of carbon sink also, because unless and until these phytoplanktons perform well, the biological pump of carbon that Dr. Akhand was mentioning, that by means of photosynthesis, the absorption of carbon that takes place acts as one of the most important sinking avenues in the present date in the ocean. However, the excessive amount of nutrients sometimes leads to the formation of phytoplankton blooms. The term bloom has been introduced in the field of oceanography to to emphasize on issues where phytoplankton growths go beyond a certain extreme and they form a kind of thin algal mat over the ocean surface. So that becomes very difficult, and that's a very challenging situation because such kind of formations often cut off the gaseous supply with the oceanic surface, and it leads to several consequences, because oxygen supply from the atmosphere towards the depths of ocean or in the euphotic surface, as we say, that is the top surface, which is the most productive surface of oceans, it gets cut off. And accordingly, due to this phenomena, all the living organisms in the oceans suffer to a lot extent. So coastal eutrophication another term is been given to this in the present day. It is known as cultural eutrophication. That is, the eutrophication is a natural process also, but cultural eutrophication means the eutrophication that is primarily caused because of anthropogenic activities. So that is a domain which requires still a substantial research in this particular, especially in countries like India. Apart from eutrophication, in nowadays, plastics have become a major problem. Plastics, as we all know, we are using plastics indiscriminately in all our daily life, and obviously plastics have some special characteristics which has made this item so popular. It is light, it is having a low density, and its strength to carry things and all these other properties have made plastic an inevitable item in almost each and every products that we use today. But scarcely do we realize that these plastics, in whichever form it is, it is ultimately going into the oceans. Owing to its light character, it can flow for long distance in the air. It can be airborne macroplastics as well. But what has become the primary concern is that the microplastics, any plastic material which is below the size of 5 millimeter, can be called as microplastics. Now, these microplastics have become a true menace in the coastal ecosystems. The reason it has become a point of such concern is that various phytoplanktons, zooplanktons, and small marine animals mistake these microplastics as foods and they ingest them. Now, microplastics have two kinds of origin. Macroplastics, that is the plastics, say for example the plastic bottles, the plastic wrappers that we use, they eventually flow through the rivers and end up in coastal ecosystems, and sunlight strikes them, water corrosion causes them, and eventually these microplastics degrade into microplastics. However, there are other cases, say for example, several cosmetic products, scrubbers, various kinds of abrasives, even paints, they have inbuilt microplastics in them. So that is also being eliminated to the oceans. Now, both these types of microplastics are very difficult to quantify in the first place, and the kind of damage they do is because of their very small structure. They are unanimously and homogeneously spread around each and every coastal ecosystem, and they almost hamper each and every form of aquatic habitat lying in the coast and the adjacent fauna and flora as well. Now, apart from microplastics, there's another major issue is the heavy metal pollution. There are several industries which is extremely necessary to carry out the developmental activities of the modern world. But all these industries are producing several kinds of trace metals as byproducts or accidental incurrences into the sewage discharge. Say, for example, chromium, nickel, copper, cadmium, mercury, even to some extent, arsenic, all these elements and metals, they are getting exposed to the open environment of the ocean, and all these metals have a certain rate of toxicity when it crosses beyond a certain threshold within the body of a particular living organism. So unknowingly, we are all consuming metals through fishes, maybe through vegetables, maybe through the rice pellets that we are eating. So all these things, all these issues are very much burning issues, and they require several kinds of research approaches to deal with. So apart from that, I won't say ocean acidification is not directly a kind of pollution, but as Anirban Akhand was saying, Dr. Akhand, that the excessive carbon influx towards the ocean is lowering the pH of the oceans also, which has also become a major point of concern. But as of heavy metal dynamics, it has really become a severe problem, especially in Indian coastlines.
Okay. Sir, I just want to highlight one of the term that, if you please elaborate, that is, like the phytoremediation of pollutants and how it's playing the role in the coastlines, coastal areas, marine ecosystems.
Yes, phytoremediation has emerged as one of the most viable options to deal with these pollutants, because you have to understand one thing. Whenever a pollutant is in a localized medium, it is extremely easy to remove that pollutant from that source. But environment or ocean, these are so vast areas, and especially even if I take into consideration only the coastal landscape, these are so vast areas, and all these pollutants, they just mix in each and every corners of those areas. So phytoremediation, the term actually means to remediate or to alleviate pollution levels by using natural plant communities. So plants are some species, or they are some living beings, wonderful living beings, which can not only give us benefits by absorbing carbon dioxide by carrying out photosynthesis, but through activities like transpiration, which is a very important activity that all the plants, have to do, carry out for their sustenance. They can absorb substantial amount of heavy metals in their body parts. Now, plants, what they do, whenever there is a sediment which you know that it has been infected by multitude of heavy metals, we can select some plants, especially I was talking about, Dr. Akhand was talking about the blue carbon ecosystems. Several mangroves, several seagrass species, even salt marsh species have shown remarkable potential to accumulate metals in their body part. Now, accumulating metal is one part. Now, the other good thing that these plants do is that by accumulating the metals, they are making the sediments free of the pollutants. So, for example, if you are experiencing that a particular agricultural field in the coastal landscape has become polluted with metals, you can say, for example, choose a particular species which is very good for accumulating metals, and you can let it grow in those agricultural fields. Those plants will just simply take up the metals and accumulate in their body parts. Now, plants have usually two kinds of adaptation strategies. One is to avoid the metal, and another is to collate or accumulate the metal in their body parts. Now, in order to avoid the metal, what sometimes the plants do, they do not allow the metals to grow in their upper part of, or in the shoots or the stems of those plants, and they just keep the metals accumulated in the roots. And sometimes it has been found, several advanced scientific research has found that these metals enter the plant body, and the plant secretes some enzymes and some biochemical reactions takes place, whereby these plants, these heavy metals, they got, in the language of chemistry, they form chelates, and they form some kind of coordination compounds, whereby the toxicity of this heavy metal is reduced. We have to keep in mind one thing, that many of these metals are pollutants only in the ionic state. Say, for example, since we are from West Bengal, we almost each and every one of us are very much aware of the arsenic pollution that takes place in many of the parts of the West Bengal. So all these pollutants, these are active in the ionic state. What these plants can do, they can convert it into a somewhat organometallic state and reduce the toxicity. And not only that, scientists are also thinking in the present day that by this way, if you can properly utilize a suitable plant species, you can collect, you can even phyto extract heavy metals from them, which you can later reuse in further industrial purpose, because you know which plant parts or which plant organs should I be looking for to get the kind of particular heavy metals. So in one way, it is cleaning the environment, and at the other way, it is acting as a source of the metals, whereby you can use it further.
So you have mentioned about the growing popularity and the use of plastics, and which are very harmful to the environment, and lots of policies are coming out there like banning plastics and all. So just I just want to know what is the present state of art on about this issue, on this issue.
Yes, plastic pollution is perhaps really one of the most happening causes, or rather points of concern that has been looked after in the present date. But unlike the other, what should I say, other contaminants or pollutants, it is extremely difficult to characterize plastic pollution in the first place. It requires extremely advanced technology, like the most used technology, I would rather say, is the Fourier transformation infrared technology, FTIR analysis. But even then, there are so many types of plastics, so many types of polymers, and so many kinds of organic compounds that build the entire empire of plastic, I should say, that it becomes really difficult to characterize at the chemical level that which kind of plastics are going into the water body and which kinds of plastics are causing the main harm. But many of you must be aware that recently a satellite photograph has observed a kind of island in the mid of Pacific, and all of the sudden such kind of an emergence of such kind of an island in the middle of the Pacific raised concern. And the people, scientific observers, especially people from your discipline who are remote sensing specialists, they found out that it is an island made up of plastic. So all the huge, large plastics, they have somehow accumulated in an oceanic gyre, and they are circulating in the mid of the ocean. And we have seen, in daily life, we are seeing pictures where not only the microplastics, but the macroplastics are strangulating the several organisms, the tortoise, the fish, even the large mammals like hammerhead whales, and all these mammals, they are getting affected by these plastics. So basically, the domain of plastic pollution, it's still open. A lot has to be done in this particular issue. And not only I'm not only speaking on the perspective of core scientific or rather chemical aptitude, but human geographers as well as social scientists must also intervene in this region, because one thing is definitely for sure, that plastics are there in the environment and it is not easily biodegradable. But apart from characterizing plastic pollution, a lot of effort needs to be given to use the already existing plastics in some other what should I say, social developmental process, so that we can save the ecosystem. I would like to mention just two things about the two very recent ideas which are being implemented in many parts of the world. One is to build roads with plastics. Many scientific community, especially civil engineers, are trying to mix plastic with pitch to make a concrete material. And several scientific reports have suggested that they increase the durability of the road, the quality of the pitch or the quality of the road as well. And in this way, we can sequestrate plastic in a place where it is not hampering the other ecosystem functions. And I have also seen eco bricks. Eco bricks is a new concept where plastic PET bottles are being used, and all kinds of plastic materials are being stuffed into those plastic containers, including some of the very, what should I say, hazardous wastes like battery and something lithium ion battery or nickel cadmium battery leachates. All these wastes are stored in plastic bottles, and they are using those plastic bottles as bricks, and they are fusing the entire plastic body in such a nice way that they can be used to make even constructed houses. Maybe 4-story or 5-story houses can be made. So in the present day, we have seen that the normal bricks are being replaced by fly ash bricks in many of the construction activities we can see. So in future, we might see that constructions are being carried out by plastics, because there is no question regarding the durability or the endurability of the plastics. That is very good. That's a very good quality of the plastic. So we must think of utilizing plastics in such a way so that it is not hampering the ecosystem. So there are lots and lots of avenues of research where both geographers, chemical oceanographers can play a key role, I believe.
Sir, just as you have mentioned that the human geographers or the social geographers has lots to play in this field. So being from the background of social geography, just population is something which always makes a concern to us, and the food production is one issue that always like makes us very concerned. So, sir, does the use of fertilizers anyway it gets any effect on the marine ecosystem, use of fertilizers especially?
Yes. Fertilizers are going to be the future issue because as Dr. Akhand was saying that the role of blue carbon ecosystem, we are giving emphasis at this point of time. But if we take into consideration, if we think for a bigger or rather far future scenario, almost all the participants, if we are of the age of 30 to 40 years old, and if we are lucky enough to live for 100 years, I don't know whether we'll be able to, given this pandemic situation and all these things that are happening. So before we die, we are most likely going to see that all the natural gases and all the, I mean, the petroleum reserves are no more. So coal, according to the latest estimate, is going to last for another 300 years. So just for the sake of argument, if I imagine a situation in, 2400 year, so practically there won't be any kind of anthropogenic emission from carbon. So as carbon dioxide, not carbon, as carbon dioxide. But apart from carbon dioxide, as Dr. Mukherjee was initially telling in her the presentation that I was listening, that apart from carbon dioxide, methane and nitrous oxide are also potential greenhouse gases. Now, all these nitrogen containing fertilizers and the extreme use of these inorganic fertilizers had increased the nutrient content in the water that I was telling while I was describing about the coastal eutrophication. But at the same time, these nutrients, there are a lot of microbial communities in this water which convert these nitrogen containing substances to nitrous oxide or nitrogen dioxide, which are potent greenhouse gases, and eventually these are emitted to the atmosphere. Now, global warming potential of N2O is much, much higher than carbon dioxide. So emitting one molecule of N2O is equivalent to 43 molecules of carbon dioxide, if I am to compare by the global warming potential of these gases. So just by getting rid of carbon, we cannot say that anthropogenic activities would stop global warming in future. We must also have to think about nitrogen and nitrogenous products and sustainable use of nitrogenous products to avoid all these kinds of consequences. So there are several types of research going on to complement this kind of, we cannot stop development or agricultural food production in the name of causing global warming, but we have to look for other alternatives which can fulfill the purpose of acting as an fertilizer and at the same time not producing or rather not allowing this nitrogenous waste to come into open oceans or open environments where it can get back to the atmosphere as a greenhouse gas. So these issues are going to be extremely burning issues in future, I believe.
Sir, lastly, I would like to just put a question on a very broader aspect. Sir, can you just, on a general basis, can you just put some light on that? What are the major polluting factors of Indian coastline in our country?
Right. See, as you all belong from the background of geography, and many of the participants are as well, I believe, one thing is definitely unequivocal is that the population is increasing, that's for sure. But the population in the coastal sector, that is within 1 kilometer buffer of the coastal region, has increased at an exponential rate in the last 4 or 5 decades. So the land use change in the coastal domain, especially in India, that you just take into account any and every study, you'll be able to see that there are significant amount, or rather drastic amount, of land use change that has taken place in the Indian coastlines, especially in exactly in this particular decade. What we are observing in Sundarban, and not only in Sundarban but also along the entire east coast of India, aquaculture ponds are emerging at an alarming rate. Now, aquaculture ponds are not only, hampering the ecosystem in a way that they are coming at the cost of several crucial blue carbon ecosystems like mangroves and salt marshes, especially, but at the same time, the extensive aquaculture requires again a substantial use of fertilizers, which pollutes these water environments, and in most of the cases, untreated aquaculture discharge water goes into the adjacent estuary and eventually to the ocean. So this is a very key criteria in the Indian coastline at this point of time. And many of the industries are situated either along the coasts or in the estuaries, which are very much closer to the coast. And there are industrial hubs. Say, for example, you can take Haldia petrochemical hub in here, in the eastern coastline, as well as I have seen papers where they have reported substantial heavy metal pollution from in and around the Mumbai coastline. So the Thane Creek in Goa, also Mandovi has experienced or observed several heavy metal pollution activities. So all around these eastern coastline, heavy metals are also becoming a menace, because fishes, as I was saying, vegetables, they are acquiring, or they are accumulating substantial quantity of heavy metal. Plastics are being indiscriminately used in India especially, and the lack of awareness to dispose plastics has made the situation even more worse in Indian coastline. So basically, if you, to make it short, if you take into account, or if you give a Google search about the type of coastal pollution, each and every kind of coastal pollution is very much prominent in the Indian coastline, and all of these require attention. The two other kinds of pollution that I haven't spoken of yet is, they are also major issues, that is oil pollution, and the other thing is noise pollution. Many of you might be surprised to hear about noise pollution, but noise pollution in estuaries, especially in tourism dominated areas, have become a major concern as well, because there are several studies which indicated that the noise produced by this continuous movement of steamers, launches and boats, they are causing, many of the marine fauna, or especially fauna only, they are trying to shift their habitats owing to these disturbances. Oil pollution has also become a very common phenomena. Previously, we used to know that accidental oil spills or ship sinking events only used to cause oil pollution, but now what we are seeing is that due to this rapid movement of these steamers, launch and tourism boats, some amount of oil are inevitably getting leaked from those boats, and it is contaminating the surface. And as we all know, that oil, whenever it comes in an aquatic surface, it cuts off the gaseous supply, and it has its consequences, very much like eutrophication. So all the, arena of coastal pollution, it exists in Indian coastlines, and each and every one of them require equal attention.
Thank you, sir. Thank you for your sharing the thoughts with us, and giving
Most
your
welcome.
So now, as we are hearing from our experts, so now I would like to request Dr. Anurai, can we have some questions from our participants?
Yes, of course. First of all, thank you very much, Dr. Abha Chandra and Dr. Anirban Akhan. You have almost touched every crucial aspects of the ocean pollution and the climate change. However, your presentation and your answers have raised certain questions in the mind of our participants. This is the first question that we got from our Zoom participants. This is for you, Dr. Anirban Akhan. Can you please say briefly what is DOM deposition? You're still on mute.
Sorry. DOM deposition is dissolved organic matter deposition. I think, I guess so. Because the question is only DOM.
Yes, I think if you can just tell one line about this DOM deposition for our students, if they can understand.
Yes, DOM is generally in the form of colored dissolved organic matter, and it can be deposited in the dissolved form from the estuaries to the deep ocean, and ultimately it can be deposited to the sediment also. So I would like to mention that previously the major form of blue carbon is deposited in the form of particulate organic carbon in the sediment. But nowadays, there are some papers, they claim that dissolved form like dissolved inorganic carbon that is also deposited in the deep sea, and it is generated from the blue carbon ecosystems like mangroves and seagrasses and deposited in the deep sea, that should be also considered as blue carbon ecosystem, because that dissolved form is also uh, um, storage for the in millennium scale.
Thank you very much, sir. The next question is for Dr. Abha Chandra. Sir, can you please suggest how someone can extract the heavy metals from the plants, and if it is possible, what are the major challenges associated with it?
Well, phyto extraction has become a very, am I audible?
Yes, yes, sir. You're
Okay,
audible.
okay, okay. Phyto extraction, there are several works on phyto extraction. The thing is that we have to know which plants can sequester the heavy metals best, because the heavy metals not only I mean, even if they are in the sediments, there is a particular property which is known as bioavailability. So there are ways in which you can make these heavy metals more readily available for the plants, and these plants can take up those heavy metals, and there are several body parts in the plant's organs, and you have to culture, or rather you have to take samples from those plants and examine that exactly which body parts are accumulating these metals at the highest level. So if you see, for example, that the nodes or the stem branchings, they are accumulating the metals at a very high level. So you can extract those parts and eventually get those recovered those metals by following chemical methods. There are several methods which are used because they are metal specific, because the different metals form different kind of organic metallic compounds. So the extraction procedures varies from metals to metals, but I believe it is possible. But of course, not only chemical oceanography or environmental chemistry, but there is a tremendous scope of genetic engineering as well. Genetic engineering is playing a very crucial role, by which they are mediating the plant hormones in such an extent that they are effective, they are becoming more effective and more quickly accumulating the metals in their body parts.
Thank you, sir. Sir, our YouTube viewer wants to know, how can we able to manage radioactive waste and also mitigate the oil spilling? And is there any biological prevention processes which can reduce the plastic uses as well?
Well, as far as biological process is concerned regarding plastics, I haven't yet heard of it, but definitely oil pollution has some biological intervention. There was at a time I know that research is going on. I believe it is still going on to produce special kind of microbial community that would only feed on the oils, and in this way they can remove the oil surface, that the oil that is accidentally spilled in a aquatic surface, they can remove this oil but simply by eating. But as far as radioactive wastes is concerned, even still today the practice is to deposit it either in the deep ocean or bury it somewhere very deep. It is very difficult to handle radioactive waste, but I am sure there are biological interventions as well. but these are very active domains of research. And honestly, I'm not an expert of all these issues, but definitely there are options, and there are always novel approaches or novel ideas coming up in these fields. And each and every passing day, we are getting new information, so which is enlightening us. So yes, of course, there are biological processes available, I guess.
Thank you, sir. So there is another query, like the construction industry with plastic. There is a rise concern, like if we incorporate plastic in more construction sectors, so how we are going to reduce the like air temperature? Like what are the challenges we are going to face for the air temperature, rise in air temperature with the increasing use of plastic in construction sector?
Well, plastics, I don't believe they directly have any correlation with air temperature in the first place. Plastics are mainly menaced because of their role that they play in the marine ecosystems and the marine mammals, fauna, and flora. But as far as air temperature reduction is concerned, of course, the more we switch to renewable energy, and the less we emit carbon or other fuels, fossil fuel combustion, automatically that will have an effect on air temperature. But at the end of the day, we have to know, or we have to accept that we cannot stop all the kind of developmental activities just in order to reduce global warming. But what we are looking for is that the term sustainable development, or as UN emphasizes, the SDGs, the sustainable development goals, we have to look for avenues wherein development would be also on, and vis-a-vis we can have some restrictions on the use of fossil fuel combustion. This is why we must ensure to conserve the blue carbon habitats, as Dr. Akhand was telling, because these habitats can store, disproportionately large amount of carbon than the entire ocean surface. And today we are thinking about conserving these ecosystems, but we have to think beyond conservation, and we have to think of enhancing the cover of these ecosystems so that new mangrove communities develop, new seagrass communities develop in the already existing barren areas, and more carbon sequestration, with more and more carbon sequestration potential, so that ultimately using these natural ecosystems, we'll be able to combat the evil of climate change. And there are various international programs like REDD plus, reduction of emission by deforestation and degradation of forest. So all these programs are existing, but the thing is that the proper implementation at the ground level, especially in countries like India, is still missing. So human awareness and more endeavor from the local community is required to combat this evil.
Very true, sir. Thank you very much for your wonderful answers. We have many questions, but I would like to stick with the questions of Shupratu Pal, who has many concern about the climate change. Actually, this is also our concern, like how this climate change and how this huge influx of carbon dioxide and the various marine pollutants are turning into the disastrous extreme events. And I think to get this answers on this observation, I would like to invite our colleague, Dr. Rajiv Sarkar, who is a young geographer who has completed his graduation, post-graduation, and PhD from the University of Burdwan. He has completed his PG diploma in advanced geomorphology, and he has completed his PhD on urban climatology. Prior joining to the assistant professorship in Adamas University since 2017, he was the resource person and the faculty in many reputed universities like Jadavpur University, Kalyani University, Diamond Harbour Women's University. Dr. Sarkar is currently working on application of remote sensing and GIS in urban planning and management, and he has also deep interest in the urban growth modeling and geostatistics. With these words, I would like to invite Dr. Sarkar to enlighten us about his observation, like how these marine pollutants or how this CO2 influx through the oceans are anyhow related to the extreme hydrometeorological hazards of the recent time. Dr. Sarkar, it's
thank you, madam. Thank you for your nice introduction. Yeah, in continuation of the lectures that we have gone through, be it our Anirban Akhan sir and or be it our Avro sir, the situation is getting changed in terms of ocean. If you look at the theme of 2021 Ocean Day, it talks about life and livelihood. And this life and livelihood are getting changed each passing day. And if you look at the different hazards now occurring in the oceans, if you compare the Bay of Bengal arena with the Arabian Sea arena, you will see a gradual shift is being taking place. We have seen cyclones to hit Bay of Bengal many more days from the initial observation that has been made. And the initial ratio of cyclones hitting the Bay of Bengal coast is 5 times higher than the Arabian Sea. But with the advent of climate change, the scenario is getting changed. Now, from 2000 onwards, more specifically 2010 onwards, the Arabian Sea cyclones are getting stronger. They are attracting more attention. The recent cyclones that hit the western coast, the Tatuk, absolutely a anomalical scenario that has emerged. And if you compare the origin, the transformation, and how this cyclone matured in a rapid way, concern the scientific community. What caused this? Because we have seen Bay of Bengal coast and the Bay of Bengal area are warmer than the Arabian Sea area, because the influx of fluids, fresh waters from the rivers basically do not allow the mixing of colder water with the warmer water of the surface. That causes a conducive environment for the cyclone to develop in the Bay of Bengal area. But this scenario is getting changed, and we see the western Indian Ocean, which is colder in nature, is getting rapid warming, and that rapid warming is very much prominent in the summertime. And this summertime, which is a pre-monsoonal season, leads to a rapid intensification, and this rapid intensification causing a severe cyclone to develop. This severe cyclone has very negative implication on the disastrous scenario, disaster management scenario. And another interesting point that is rising from this rapid intensification is that the way we predict our cyclones is getting very difficult, and it is getting very much complex. As rapid intensification is happening, we the scientists and even the IMD are facing a lot of difficulty in understanding in which direction it is going to hit. So as a broader scale, the climate change, most specifically the warming of ocean water, is causing a very devastating scenario in the terms of cyclone management, disaster management, and cyclone prediction on as a whole. Hello, madam. Are you there?
Yes.
Yes. Thank you, Dr. Sarkar, for giving another kind of a view about the natural disaster, natural hazard we are facing. Just a few days ago, we have faced another one, and it is getting increased day by day in the recent times, as we know. So thank you for your insightful thoughts and sharing with us. Thank you.
Thank you very much.
Yes. Now we would like to take a few questions again. That one question is there for Dr. Chondo, and that is in earlier times we could see a quite number of dolphins in Lake Chilka, but the number is decreased in recent times. Is noise pollution is the reason, one of the reasons behind that?
Well, yes, as far as I'm not a marine biologist though, but still from my basic knowledge, I know that dolphins are, yes, very much sensitive to noises. But we have also seen often that they reciprocate with the moving ships and all. There are many videos that we have seen in YouTube or Facebook that dolphins are moving at par with the ships. But yes, noise level is definitely a factor. And apart from that, dolphins are also very sensitive to coastal pollution as well, because dolphins, according to marine biologists, they are considered as indicators of waters which is very pristine. So if a dolphin or a dolphin community shifts from a particular place and leaves the habitat, so it also indicates that there might be signatures of coastal pollution. And Chilka Lake is at present experiencing some form of coastal pollution, though it is very well conserved, perhaps one of the most well conserved ecosystem in this country, but still the signatures of pollution is not absolutely not there. We cannot say so from the kind of publications that we have seen in the recent decade.
Okay. There is another question to you, sir, that is there only one way to just, should we only initiate the promotion of organic fertilizers to check the problem related to the fertilizers, as you have said? Is this the only way, or there are some other ways also?
No, of course there are other ways, because even if see, the problem is not using inorganic fertilizer. The problem is the runoff that is driving those inorganic fertilizers to the estuaries or oceans. So if you can restrict that runoff, or if you can implement genetic engineering in the agricultural field as well, to convert those nitrogen into in some form which is not a greenhouse gas, say for example nitrogen fixing bacteria and all those things. So these kind of genetic engineering interventions are also possible avenues by means of which we can convert the inorganic nitrogen to organic form. So as soon as it is going into organic form, as Dr. Akhand was saying about POC and DOC, that is dissolved organic carbon and particulate organic carbon, similarly there are PON and DON as well, that is dissolved organic nitrogen and dissolved particulate organic nitrogen. So nitrogen or carbon in the organic form, and when it is in the sediment, it is not causing any harm to the environment. But as soon as it is transforming itself into a greenhouse gas, that's when the concern begins. So I believe there are many options, and we have to think out of the box as well. So it is a time where several new ideas are developing, several eager young minds who are at present perhaps listening to this kind of discussion, they might come up with some new completely different approach in 10 years of time. So I'm optimistic that there are several other ideas should develop and are also at present working out, chalking out. So not only that you have to abandon inorganic fertilizer and switch to organic farm, I'm sure there are other avenues as well.
Okay. Thank you, sir, for the answers. Now, I would
I
like
have
to...
a question.
Yes, sir. Yes, sir.
I have a question to Dr. Rajiv Sarkar. Rajiv, are you there?
Yes, sir, I'm here.
Okay. I am asking about this ocean day. Why, the ocean is behaving like, there's so much irregular way that is why I want to mean why this cyclone it becomes so frequent in this part of the country. It was not so frequent in earlier days.
Yeah, sir, the point is that, thank you for your question. If you look at the 120 years record, we see near about 300 cyclone originated in Bay of Bengal. And the cause is that the water, fresh water, which is coming from river Ganga, river Brahmaputra, they as usually do not mix well with the cold water which is beneath the surface water. And this water basically evaporates at the time of pre-summer season and generates a system of cyclone. But if you look at the Arabian Sea, and another point is that if you look at the configuration of the Indian Bay of Bengal coast, that also helps in generation of the cyclonic system, because the wind parameter that is also very much important for the genesis of the cyclone is slow enough for dissipation of the energy which is coming from the evaporation. But if you look at the Arabian coast, the configuration of the coastline of the Africa part and Indian part is such that it allows the wind to flow more, which leads to dissipation of the energy which is accumulating over the surface water. That is the reason we see higher amount of, or higher quantum of cyclonic genesis in the Bay of Bengal from mixing of fresh water, which is not getting time to mix well with the colder water, and hence is getting evaporated in quick time. And on the other case, Arabian Sea, wind parameters are higher.
Yeah, this is fine, but usually what happened last few years, we used to hear that we have a cyclone, but this is moving towards Bangladesh or moving towards Andaman, and our coast is not affected. But last few years, our coast is getting affected very much. So what is the reason for this? It's not moving towards Bangladesh. So,
you are saying that what is the cause of drifting of the path from the initial scenario, then the present scenario.
Right.
Now the situation is such that that area, very important question, sir, the area from where it is now generating is very closer to us. Previously, we would see the cyclone genesis was scenario very close to the equator. Now it is coming closer to us. So when it is coming closer to the Indian coast, it is getting warmer in a rapid time. Rapid intensification is taking place. Now, when this rapid intensification is taking place, the configuration of the coast is allowing the path to be shifted. In the earlier case, when the rapid intensification was lowered, the path was towards the Bangladesh, because it took time, and rapid intensification was lowered. It followed the curve of the coast, and followed, as long as it followed the curve of the coast, the path was towards the Bangladesh. But now, as the rapid intensification is happening with no time to identify in which direction it is going, then this path is basically broken. That is why, sir, we see a change in the trajectory of the cyclone. And there's a very interesting part.
Yeah, that is fine. Now, one thing that geographers or climatologists or weather scientists, they can predict this cyclonic weather or cyclone previously, in a very accurate way. Last two cyclones we have seen. But is there any research or anything about scientists or climatologists or geographers thinking how to control this cyclone? Is it possible to control the cyclone somehow?
Sir, cyclone control is near to impossible. Because why it is impossible? Cyclone is basically one of the important natural transporter of energy from the equator to the upper latitudinal area. So if you just drop a hypothetical situation where the energy is not being transported from the higher energy level to the lower energy scenario, then the system will collapse, because here the energy will accumulate and there will be no way the energy will dissipate. So I don't know, and I don't know whether any research is going on in this particular domain. But in 2017, NASA Geophysical Fluid Dynamics Laboratory has made a good prediction about the intensification of cyclone in the Arabian Sea. Because if you look at the Western Arabian Sea, which is Western Arabian Sea current, which is colder in nature, that is getting warmer in a rapid pace. That rapid pace intensification of warming basically leads to, sir, the more cyclones in the Arabian coastal areas. And that is very interesting part. And when this rapid intensification is taking place, the problem is that, sir, IMD, which are monitoring the path and trajectory and allowing us to evacuate the areas, they are facing this trouble. How to predict the path? And it is basically getting random. They are not getting appropriate prediction at which location the landfall will take place. So this scenario is occurring, and they are now making more efficient model so that the path and landfall site can be predicted well.
Okay, thank you.
Thank you, sir. Thank you.
Professor Ghosh and Dr. Sarkar, can I add something else if you would allow?
Yeah, yes, absolutely.
Sure, sir.
First of all, I would like to convey my regards to Professor Ghosh, because I used to be a student of Presidency College and he used to be our principal, sir.
Thank you.
So,
You are a
what
student
I
of which year?
2009 postgrad, sir, environmental
Okay.
system management.
Okay.
And
So you are a
what I,
student of Ashish.
yes, and Horendranath, sir.
Yeah. Okay.
What I would like to add, along with what Dr. Sarkar was telling, that this time what we saw in case of yes, particularly, and especially the last few cyclones that are taking place, from the eye of the cyclone, the radius of the entire the cyclone genesis system, this entire area is somehow, I believe, it's increasing. In the recent decade, this area is increasing. Even in this particular case, if we see, it was not the strong winds that impacted Sundarban coastline or West Bengal coastline. It was the associated storm surge that led to the main destruction. So the storm, the eye of the cyclone passed through Digha Balasore coast, but even then, in Kalighat area, where the high tide never reaches water in Kolkata, it
Right.
inundated substantial areas of Kolkata. So embankment system and disaster preparedness should reach a new height to combat this kind of atmospheric disturbances. Otherwise, there is no other alternative to combat this kind of disaster.
And the amount of disaster, say for Tatuk, has caused a 2.1 billion loss. So, sir, if you see that in pre-monsoon scenario, when April-May month, if two cyclones hit India
Yes.
every year, we are going down economically. Because managing all the staffs and bringing the resilience of the community is very tough.
Furthermore, the agriculture will be, somewhat hampered because all the micro, pollutants and other domed and other things are coming to the soil, and they're not getting back to the sea
Absolutely.
once again. So they are going to stay for a while, and that is causing, agriculture to, affecting agriculture also.
Absolutely.
Yes.
Thank you. Thank you very much, sir. Thank you. Now, I would like to invite Dr. Tuhin Bhadra to speak about the career prospects in geography, in oceanography, because from the first to till our last chat box, the many questions are posted here about the career prospects in the oceanography or in marine studies. So before inviting Tuhin Bhadra on mic, I would like to introduce him. He is presently working as an assistant professor of geography in the School of Basic and Applied Sciences at Adamas University. He received postgraduate degree in geography from Rabindra Bharati University with specialization in fluvial geomorphology. He received his MPhil degree in oceanography and coastal management and postgraduate diploma in remote sensing and GIS from Jadavpur University. He also received his doctoral degree on hydrology and water resource management from the School of Oceanographic Studies, Jadavpur University. During his doctoral research, he received Newton Bhabha Fellowship, sponsored by British Council UK and Deputy Government of India, to attend a PhD internship at the University of Edinburgh, Scotland, UK. His research interests includes the fluvial geomorphology, hydrology and water resource management, coastal zone management, hydrological and hydrodynamic modeling, ecohydrology, remote sensing, and GIS application. Now, Dr. Tuhin Bhadra, can you please introduce us about what are the career prospects are associated with this oceanography and marine studies?
Thank you, Dr. Onurai, for this introduction, and also thank you for giving me the opportunity to discuss on the topic. So we all know that oceanography is a branch of science which mainly deals with the physical, chemical, geological, and biological properties of ocean water or ocean. So if you allow me, I can share a few slides on this topic. This is mainly for the students.
Please, sir.
Is it visible?
Yeah, it's coming.
Yes, it's visible.
So these are some specialized field in oceanography where a student can develop their expertise, which includes biological oceanography, which mainly deals with the flora and fauna of ocean. Then chemical oceanography, which deals with the chemistry of ocean water. Then geological oceanography.
Sorry to interrupt. Could you please put it in the slideshow mode?
Okay.
That will be easy. Yeah. Okay.
Is it okay now?
Yes. Yes.
Then geological oceanography, which mostly related with geography, geology, and mainly deals with the ocean floor and their morphology and with plate tectonics. And then physical oceanography, which mainly deals with the ocean water mass, their intermixing pattern, waves, tides, and currents. Then marine engineering, which is almost a different topic and mainly related with the field of engineering, which includes the engineering of boats, ships, and any instrument or equipments that can operate in offshore or coastal region. And then marine policy, which is mainly related with the rules and regulation which govern the matters relating sea and ships. Then marine archaeology, which is kind of a branch of archaeology and deals with the physical remains. And then satellite oceanography, which is an emerging field of oceanography, and students of geography can contribute in this field. And here, mainly the researchers use the satellite images or remotely sensed data to interpret the temperature of ocean or height of water level in the ocean, wind speed or ocean color, or to monitor coral reefs, the sea ice, or ocean bathymetry, and many more things. And there is another field which is not a part of this core oceanography, but very much dependent on this oceanography. There is coastal studies, which includes this coastal and offshore engineering, coastal geomorphology, hydrology, pollution, or tourism part, or data studies, or integrated coastal zone management, or mangrove ecosystem, shoreline modeling, or storm surge modeling, and also the socioeconomic studies of coastal communities, and also the sea level rise and its impact. So now I'll discuss the main eligibility criteria to read this oceanography as a subject. So most of the Indian institute and universities offer postgraduate degree in oceanography, and the minimum educational qualification required to study these programs are bachelors of science in zoology, botany, or any biological science, and chemistry, physics, or art science. Some university also offers MPhil or PhD program in oceanography. So these are some of these university which offers these postgraduate degrees. These are Andhra University, Andamala University, Cochin, Berhampur University, India's Institute of Technologies, Goa University, Mangalore University, and in Kolkata, Jadavpur University offer MPhil in oceanography and also PhD. Students of geography can opt for this program. And University of Calcutta offer MSc in
I think there is some technical issues. Dr. Bhadra?
Okay, just wait for 1 minute.
Hello? Dr. Tuhin Bhadra, you are not audible.
No, I think there is some connection issues. I think.
Yeah,
Yes.
So we can wait. We can wait.
Yes, yes, definitely.
Yeah.
Okay, he got disconnected. I think he'll join back us. We can see here several queries regarding the feedback form. Dr. Anurai, could you please address the audience if there is any problem for the feedback?
Yeah, I have again posted.
I think.
He is joined. Okay. Meanwhile,
Yes.
I have again posted the feedback from the longer link. Please check whether it is working or not, because we have already received 56 responses, and so I think it's working. The link is working properly. You can please recheck again.
Okay, now I think Dr. Bhadra can continue.
Yes. You are on mute, sir.
Is it okay now?
Yes.
Hello.
Yeah.
Yes.
Yes.
So this is an emerging field, and to gain knowledge on the field, or we can also get jobs or apply private or public jobs after studying oceanography. So the next slide. The slides are not changing. Just a minute. So Union Public Service Commission generally conduct tests to place oceanographers, and the Geological Survey of India or Marine Exploration Authorities, Oil or Natural Gas Corporation, Hindustan Zinc, or many other agencies who are directly involved with this exploration. They hire geological oceanographers, and next these are some government organization where the oceanographer can find their jobs, which includes the Indian National Center for Ocean Information Service, that is INCOES, then National Institute of Ocean Technology, Department of Ocean Development, Center for Marine Living Resource and Ecology, National Center for Coastal Research, and National Center for Polar and Ocean Research. So finally, these are the following fields where the oceanographers are mainly hired. They can be act as marine technician, marine policy expert, hydrographer, marine archaeologist, biologist, or marine environmentalist, marine and ocean engineers, marine geochemist, fisheries experts or research associates, ocean imports managers or freight manager for defense purpose, or for coastal zone manager. So that's all. Thank you. Over to Dr. Onurai.
Thank you very much, sir, for your quick and very informative presentation. Now, in among the audience, if you have any queries or if you want to interact with any of our speaker or any of our panelists, you are welcome on mic. Any one of you, if you want to say something,
Yes. Now you can just unmute yourself and directly interact with our.
I have seen
Yes.
someone has. Would you like to say something, Dr. Arun Kumar Singh? You're not audible, sir. Actually, I think if any one of you want to say something, please raise your hand or unmute yourself. And if you want to interact, you can continue.
I see Arun Kumar Singh sir has already raised his hand.
But he has raised his hand, but he is not saying anything, I guess. Sir, you are not audible. Have you connected with your mic?
Okay, then I think we can go for the next stage.
Okay, I would like to close this session and would like to invite our colleague Dr. Mansi to please convey vote of thanks.
Please
Mansi,
unmute. I think you are on
Mansi,
mute. You are on mute.
Yes.
Thank you.
Hello, everyone. This is Mansi Devnath, and honorable dignitaries, distinguished speakers, respected Chancellor, Sir, Dean, Sir, and dear participants. On behalf of the Department of Geography, School of Basic Sciences, SOBAS, entire fraternity and organizing committee. I'm Manasi Devnath, as an assistant professor Phil Mains, pleased to take this opportunity to propose vote of thanks to our eminent speaker, Dr. Anirban Akhan. And he has given a beautiful speech on a discussion on the blue carbon. And then I would also like to propose vote of thanks to Dr. Agrachandra, and who has said, who has given us an immense knowledge on eutrophication, how our human activities like sewage of heavy metal and then macroplastics affects the eutrophication. And vote of thanks also proposed to Dr. Kosturi Mukherjee, Dr. Rajiv Sarkar, Dr. Tuhin Bhadra from Adamas University for exchange their valuable knowledge on the panel discussion on climate change and ocean. We really honored to listen all of you in this event that inspired us as a cohort of the stream of science. I would also like to take an opportunity to express my sincere thanks and gratitude to Chancellor Dr. Samit Roy, VC Dr. Devendra Jha, for always being with us and encouraging us, providing measures and opportunity to conduct such events. I would specially thanks to our SOVAS committee, Dr. Professor Sanjeev Ghosh sir, Dean of the SOVAS, Professor Jitendra Kumar Pandey, for stand by us to give us unconditional support that helps keep and motivate us. My sincere gratitude and thanks also goes to all the participants who choose to live with us and attend the entire webinar via Zoom as well as via YouTube. This makes our event a great successful. Lastly, but not least, I also like to thanks to our HOD, to Dr. Anurai, to Dr. Sukriti Karmakar for all the technical support related to the communication and handle the technical sessions. Lastly, I would like to add one recent information that International Hydrographic Organization, NOAA, and National Geographic has recognized the Southern Ocean as the globe's fifth ocean in recent World Oceanic Day in 2021. That is surrounding the Antarctica. So now I'm just giving the mic to Dr. Anurai.
Thank you, Mansi, and thank you our esteemed speakers, our participants, and all of your who have really made this session a wonderful session. We are supposed to end by 1 p.m., but it is just because of your interaction that we have stressed up to 1:40. So thank you very much, and we would like to invite you for our next webinar. You will get all the information on our website, on our Facebook page of the Department of Geography. Thanks. And welcome you back again. Thank you very much.
Thank you all.
Thank you.
Thank you.
Thank you very much.
Thank
you all for inviting.
Thank you, sir.
Thank you, sir.